Hi, my name is Solomon Abell, and I'm in Miss Ellis's 4th period chemistry class. I will be talking to you today about the chemistry of poison dart frogs, and I have my pal Jeffrey here to help me out. So, I first got interested in frogs when I went to a talk by a frog biologist who talked about how we're really destroying their habitat and how important they are to our ecosystem. So, this is an example of how many species of just poison dart frogs there are, not even just frogs, of which they span 13 genera, and there are over 175 different species of poison dart frogs. Now, their range is in the jungles of Central and South America. They love the humidity, so they love to hang out in the Amazon. Now, this is an example of the warning colorations, or it's a great example of aposematism, which means away sign, literally, or warning coloration in these frogs. That was the blue poison dart frog, like Jeffrey here, the yellow banded poison dart frog, the rainbow poison dart frog, the strawberry poison dart frog, here sitting in a mushroom cap, strawberry again. More examples of coloration. Now, their size can range from anywhere between up to as big as 6 centimeters long, so about that big, to smaller than 1.5 centimeters, so that's smaller than between the tips of my fingers there. Again, great examples of size and warning coloration, both in those two pictures. Now, poison dart frogs are so named because tribes in, notably Colombia, notably the Noa, Nama, Choco, and the Embero Choco tribes of Colombia, use these frogs to coat the tips of their poison darts to make them deadly so that they can more efficiently hunt. Now, the only frogs that have been known to be used for this purpose are in the Phyllobates genus, and the toxin that's specific to this genus is a toxin called Batrachotoxin, which will be the focus of the remainder of the talk. Now, the frogs in the Phyllobates genus are the Phyllobates bicolor, or the black-legged poison dart frog, the Phyllobates oritania, and the Phyllobates terribilis, the golden poison dart frog, which is by far the most toxic, and maybe the most toxic animal on the planet. In its skin, it can carry enough toxin to kill up to 10 to 20 men. Now, this is what batrachotoxin, the molecule, actually looks like. So you can see it's got a 4-carbon ring here. Now, all of the toxins that these poison dart frogs carry are lipophilic alkaloid toxins. So this is the lipophilic end, the fat-loving part of the molecule, and this is the alkaloid part, or the toxic part of the molecule. You can see alkaloid because we have the nitrogen there. And this steroid skeleton is used throughout nature. In our own bodies, we have cholesterol, from which we synthesize our hormones cortisol and, of course, testosterone and estrogen. Now, the batrachotoxin family is actually a family of toxins. I will be focusing on this one, which is the batrachotoxin, pictured here. This part plus where this R is here. Now, the frogs don't actually make this toxin. They get it from their diet, which consists of lots of these tiny beetles called mellurid beetles. Now, the beetles actually synthesize the toxin from their diet, which consists of decaying plant matter. Now, the frogs have developed specialized sodium channels so that they're not affected by the poison, which is kind of cool. Now, the way batrachotoxin actually works is the lipophilic end, that 4-carbon ring, the 4 carbon rings, allow it to enter through the cell membrane, the phospholipid cell membrane, and then from inside the cell enter a sodium channel, which there it binds to the sodium channel, holding it open. That then, irreversibly binds to the sodium channel, holding it open. So that then allows the passage freely of sodium ions, which depolarizes the cell membrane, and effectively, if this happens to a nerve cell, it can't fire. So, when it holds it open, it depolarizes the cell membrane, the nerve can't fire, that results in paralysis. Now, the cardiotoxic effects of this batrachotoxin, it almost selectively attacks the heart, so the victim actually first dies of heart failure or cardiac arrest. So, yeah, not good animals to eat or anything, but he's so cute.
And